Okay, so let's talk through this. It's a fairly simple idea, but you have to do the following. So the plan is your turn, lab. You have your own piece of paper. Your job today is to prove the following statement is false. So the statement says concentration does not affect the rate of a chemical reaction. That is a straight up lie. And you probably already knew that, but now you have to prove it with data. Okay, so the whole point today is to prove that this is not true. Okay, to do it, you have to do an experiment in the lab with hydrochloric acid and magnesium. Now, you will need to turn in a paper that looks like this one. This one was really good. So it is the exemplar work that I'm going to want you to do. So you have to have some sort of title. So they put the effective concentration on reaction rate. All right, that's their title. Then an experimental design box. That goes back a long ways. But an experimental design box has a problem, hypothesis, IV, units is covered up, treatment, trials. I want you to do 3 different treatments here. You can choose whatever you want, but they need to prove that concentration does affect the reaction rate. All right, then your DV, your units, and your constants. Oh, your table needs to look like this. Then the balanced chemical reaction. If you have good eyes, you can copy that right now. I'll do it again later. Then a list of your procedures. This girl wrote processes. That's the same thing, so I was fine with that. Then your data table right here. This data supplied gave a good defendable argument that concentration did did affect the reaction rate. All right, then you have to graph it. So looks like something like that. It doesn't really. And then your conclusion. Based on our results, we can tell that the concentration did affect it by doing whatever you found. Okay, I will have this up throughout the lab. I'll put it on this other screen though. Okay, here you go. This is what you have. You have 3 molar hydrochloric acid. This is pretty concentrated. You must be careful, and you need to wash your hands when you're done today with water. You need to wear your safety glasses or your own personal glasses the entire time. When you're done with your glasses today, please put them in this empty one, and then I'll disinfect them after. I have enough now that I only have to clean them at the end of the day. All right, so next is the magnesium strip. You can get that from me. They're about 1 inch long. If you need, I can give you up to 2, but not more than that. You'll just grab that from me. There's rulers back there to make sure that everything's the same. Then lab supplies. Pipettes, test tubes, graduated cylinders, rulers, scissors. There's all sorts of things that you can use to get this process done. Pretty much everything you need is on that cart back there. If you think you need something else, ask me and I'll go get it for you. That doesn't mean a Mountain Dew. Well, sorry, you're an elite athlete. A milk? Oh, a nuke? I don't have that. I do have nuclear material in the back room, but not a nuclear bomb. All right, so this is kind of a culmination of a ton of things that we've done throughout the entire year. How do we find the rate of a chemical reaction? All right, the rate equals change over time. The change you're measuring today is simply how long it takes the magnesium strip to react, like to disappear. It will start reacting the moment you drop it in. The time, how long it takes for it to completely disappear. Okay, fair enough. On your procedures, make sure you account for the things that you are going to keep constant. So they are written in your, right here, constants right here. They're written there. But in your procedures, make sure you account for them. So if you're going to get the same amount of liquid, then your procedure better say, I got 3 milliliters of whatever. Okay, this is 100% up to you from now on. I would visit with your lab partner, come up with a plan, and then execute that plan. Okay, have fun.
Oh boy.
Oh boy is right.